Welcome to Chip in Detail. I have with me a very unique development board. This is the NLN500a LoRa Arduino compatible EVK from System Level Solutions. The company sent me an engineering sample a couple of weeks ago for me to tinker with. In this video, we will do a detailed overview of the board, then we will see how easy it is to set up Arduino IDE for working with this board. Later, we will learn to flash a sample code and finally discuss about the custom library provided by SLS. NLN500a LoRa Arduino compatible EVK from SLS has the NebuLink NLN500a SoC Module, which integrates the world's first LoRaWAN Integrated SoC called STM32WL. This module is WPC certified and can work in LoRa frequency bands as following. For EU from 863 to 870 MHz, for US from 902 to 928 MHz, and for India at 865 MHz. Furthermore, the module consumes only 1.6 microampere in standby with an operating voltage range between 1.8 to 3.6 volts. In terms of security, there is hardware-based AES 256-bit encryption. The module supports up to 43 IOs, has 256 kilobytes of flash, 64 kilobytes RAM, and supports OTA, SWD, and JTAG. There are 2 SPI, 3 I2C, 2 USART, and 1 LP UART. Now that we understood the capability of the NebuLink NLN500a module, let's do a hardware overview of the LoRa Arduino compatible EVK, which is based on this module. The NLNA500a module is this circuitry enclosed inside the silver colored shield. The module itself has an UFL external antenna connector. I have connected the provided helical antenna on it. Now let's discuss about the pins. The cool thing about this board is that it's both compatible with Arduino IDE and also shares the same pinout as an Arduino Nano board. Let me show you this side by side for easy comparison. You can see that both boards have 2 rows of 15 GPIO pins on either side and they exactly match in terms of functionality. Also, you can flip the board and see all the pins marked properly. This will make it easy to wire up stuff without referring the pin out all the time. Now you may ask, what are these 5 pins for? These can be used to hook up an external ST-Link V2 programmer to be used along with STM32Cube programmer and other STM32 tools to change the configuration of the STM32 chip or for uploading the program. Thankfully, LoRa Arduino compatible EVK is configured in such a way that you don't need an external programmer to flash new code using Arduino IDE or STM32Cube IDE. You can directly flash the code through the USB like any other Arduino board or ESP32 board. The board has 4 screw holes on 4 corners to easily mount or secure it anywhere. This tiny package handles the USB to serial conversion. The rest of the circuitry here handles the power regulation and delivery. I appreciate that this board has the more durable and expandable USB-C port. This makes it easy to plug and play. The final hardware feature we have to discuss are these 2 buttons. The one closer to the USB-C port is the boot button and the other is the reset button. Most of you probably know what this is for, but still I will explain. See, there are 2 modes that this module can be working in, user mode and programming mode. User mode is the normal mode where you power on or reset your board and it runs the default code that is flashed. The programming mode is for making the module ready to accept new programs and save it. Only in this programming mode can we upload any new code. Now might be a good time to learn the sequence of button presses required to enable the programming mode. Assuming that you have already connected the USB-C port to your PC, now first press the boot button. Keeping the boot button pressed, press and release the reset button. Now release the boot button. There is another way to do this too. If you have not yet connected the USB-C cable to the board, then just keep pressing the boot button. While it is pressed, connect the USB cable and then release the boot button. Remember that only if you set the board in this mode, you will be able to upload code from the IDE. Before we go into the IDE setup, please check my LinkedIn post given in the description if you are still confused about the difference between a LoRa SoC module and a LoRa modem or transceiver. Let's do the Arduino IDE setup for the board. First, make sure that you have installed the latest version of the Arduino IDE. Now search in Google for STM32 Duino. There will be a GitHub page like this as the first result. Scroll down and under Getting Started, there will be a GitHub link to an index.json file. We need to copy this and use this in the Arduino IDE to pull the necessary SDK for working with STM32 on Arduino IDE. For now, just copy this link and save it. I have provided all the links in the description. On the Arduino IDE, click File, then click Preferences, and now a window will pop up. Click this icon for additional board managers URLs. Now paste the STM32 Arduino JSON link here and save and close all new windows. Now under Tools, go to Board and select the board manager. Now search for STM32 and install the one and only board file here. You can see that this supports the STM32WL which is in our board. This will take some time to download and install. Once the installation is done, if you try to upload any sample code, it will output an error like this saying STM32Cube programmer is not in your path environment. To fix this, you need to add the path to environment variable list. As this might be too advanced for many people, let's do the easy way. This can be rectified by downloading the STM32Cube programmer app from official site and installing it. I have provided the link to the software in the description of the video. Click Get Software and download the appropriate OS version and install it. It is recommended to do a PC restart after this. Now open the Arduino IDE. In the Arduino IDE board options, we need to configure accordingly for us to flash any code to our board. Under Tools, go to Boards and under STM32 Boards Groups, select Generic STM32WL series. Next, under Board Part Number, select the generic NLN500a CIX. After that, leave all of the below options as default, but change the upload method to serial. This is important. Now, connect the board to your PC and in the device manager, find the correct COM port of the board. For me, it is COM5. Make sure this COM port is selected under port option. Now our IDE is configured to upload code. Take any I2C sensor you have lying around and connect it across A4 and A5 pin. A4 is an I2C SDA pin and A5 is an SCL pin. I am using a BME280 here. Our intention here is to show you how similar to programming an Arduino, programming this LoRa board is. We are going to scan the I2C address of the BME280 sensor. Go to Examples in Arduino IDE. Under Examples for generic STM32WL series, select Wire and then select I2C scanner. If we directly upload the default code, it will not work as STM32WL has 3 I2C bus and we haven't specified in the program which I2C bus we have connected the sensor to. If you look in the comments of the example code, it's clearly mentioned. Please understand that the pinout of the dev kit is not similar to what pin it is connected internally to the MCU. For that, we need to refer official documentation given by SLS. Please note that as the documentation is not yet finalized, all documentation need to be requested from SLS and is not available in public as of now. I have provided the contact link to SLS for getting these documentation in the description of this video. Let's look at the pin details of the dev kit. When we look at the pin mapping corresponding to A4 and A5, we can see that the MCU pins are PB9 and PB8. The Arduino code command has already sample configuration for these pins. We just need to copy these 3 lines and paste it here, replacing the line before. Now save the code. After putting the board in boot mode, upload this code. Once upload is done, open the serial monitor and set the correct baud rate and you can see that the I2C device is detected and its address is shown. This is similar in terms of code and output behavior if we used any other Arduino board. From here on out, you can build a weather station like how you would do for an Arduino board. This is the simplicity of using the LoRa board from SLS. This ease of use allows for rapid prototyping. Now regarding the LoRaWAN capabilities, SLS is building an extensive library with lot of examples to easily integrate LoRaWAN capabilities. As it is still under development, the GitHub repo is not public. If you want to test out the library yourself, you need to contact SLS, and I have provided the details to contact them in the description of the video. I have got access to this library. Like any Arduino library, you can download the library as zip file from GitHub and go to Sketch option in Arduino IDE and click Include Library, then select Add Zip Library and add this library. Once the library is added, if you go to Files, then click Examples and go down, you can see the examples. These examples work, but as I don't have any LoRa gateway near my locality, I was not able to test its capabilities. I was recommended to use Sendra Gateway Network Provider. You can easily register a device and configure the network ID, application ID and device ID in the example Arduino code and easily test the LoRaWAN capabilities if you have a gateway nearby. We have come to the end of the video and you can like and share the video if you found it useful. Also, don't forget to subscribe to Chip in Details for more such videos.